This is the second part for complex numbers. A complex number such as z equals x plus y I can be expressed in trigonometric form, where we would say x equals r cosine theta and y equals r sine theta, and that then combines to z equals r cosine theta plus I sine theta. You can also see, this is in the book, that when you square this one and when you square this one and then add, you're going to come up with r squared equals x squared plus y squared, because of the and it looks like a Pythagorean, of course, and the reason it works is when you square cosine and you square sine, you come up with cosine squared plus sine squared, which is 1. So on one side you're just going to come up with r squared. And you can also see that if you divide these two here, x divided by y, the r divides out, and oops, the other way around, y divided by x is the r divides out, and sine divided by cosine is going to come out to tangent, so tangent theta equals y over x. So that's all I'm going to do here for a substitute for a lecture. So let's do a couple of problems. Write each complex number in standard form. So 2 cosine 30 degrees plus I sine 30 degrees. Well, 2 times cosine 30 is going to be 1.73, which is the square root of 3. And 2 times I sine 30, well, sine 30 is 1/2 times 2 is 1, so it's simply I. Of course, this only works if both of these here, cosine and sine, I sine here, have the same factor in front of them. So over here, that's pretty much, it's exactly the same problem, except there's another factor 2 in there, and that actually means there must be a 2 in here as well. This one here doubles from 1.73 to 3.46, and this doubles from 1 to 2. Write each complex number in trigonometric form. So 3 minus 4i, this is what I said earlier, that you have that in the book, that r squared equals x squared plus y squared. So 3 squared plus negative 4 squared, take the square root of that, 9 plus 16 is 25, square root of that is 25. And theta equals tangent negative 1 of y over x, and that comes out to, on your calculator, as a negative 53 degrees, which puts us in the fourth quadrant. Therefore this one is 370 degrees. The fourth quadrant actually is correct, because that's where the cosine is positive and that's where the sine is negative. So 370 degrees. So therefore the answer is 5 cosine 37 plus I sine 307. Could be written a little bit different. This one here is again negative 53, since cosine is an even function. Cosine negative 53 is the same as cosine of 53. And this one here could be written as sine of negative 53, since sine is an odd function, that plus I sine 307 turns into negative I sine 53. And then over here, almost the same problem, except there's a plus in between. That does not influence the r, so that's still 5 because of these here squaring gets rid of the negative. I'm sorry, over here actually. This one here squaring got rid of the negative. That's why it's still 9 plus 16 either way. Square root of that is 5. Tangent negative 1, inverse tangent of 4 over 3 equals 53 degrees, which is in quadrant 1, which is true because the cosine is in positive cosine is in quadrant 1, and positive sine is in quadrant 1 as well. And therefore at the end it's going to be 5 cosine 53 plus I sine 53.